All right, so as a machinist, one of the other areas of knowledge that you have to have is a good idea of the materials that you're going to be working with. So, Chapter 5 in our text goes through and gives some basic information on materials. Um, it is not at all comprehensive. There are well over 3,500 different types of uh, grades of steel out there, and that's just in the realm of steel, not to mention some of the other materials that we might need to be familiar with. Now, no machinist is, or I would hesitate to think that any machinist out there is familiar with machining every single possible material that is available. And of course, certainly, depending on where you go to work, you're going to specialize in certain types, and you're going to be using a lot more of different types of material one over another, depending on what the machine shop specializes. And of course, some of them are related to the industry that people are working in as well. So aerospace industry uses a lot more of aluminums and titaniums that are lighter weight but still strong. The automotive industry uses a lot more of different types of low carbon or hot roll type steel, depending on what they're being used for. But there are lots of potential applications, and we need to, as machinists, need to be familiar with material. Um, so this is going to basically, here in Chapter 5, going to go over just some of the basic knowledge. And of course, here at Richland, in the industrial materials class is a class that you'll take to learn a lot more about all of the different types of industrial materials that we work with. So we're going to start a little bit here with this PowerPoint lecture to kind of give you an idea of how material is identified. It's going to go over what we refer to as machinability, and you need to understand a little bit about what we're talking about when we say machinability. We're going to talk about how you might need to utilize the different forms or shapes that our materials are going to come to us in. And then we're going to talk about some other aspects here of material that you need to be aware of as a machinist. So we will talk about the different types of alloys. So alloys, of course, are a mixture of different types of metals and minerals. And each of these have different types of combinations. We'll talk about the heat treating conditions. Hardness and softness are somewhere in between. A little bit about what it means to anneal something or to work harden different things. And then, of course, we'll talk about all the different ways that our material is going to come to us when we're getting ready to put it into the machine and actually start machining it. So as you take a look at it, there are a couple of things that you will probably need to be aware of. So in terms of material, usually there are things that we call a heat code when it's coming from it. And generally there are some color coding there that goes on depending on which manufacturer you're buying it from, whether it's hot rolled steel or tool steel or carbon, low carbon, high carbon. There is some color codes that you might need to be aware of, and of course your supplier basically also marks the bar at the end. And you don't want to get rid of that. You want to make sure that that is identified until you've used up the whole bar so that we don't waste material. Because while we can do some certain tests to try to identify different types of material, really the only way to ensure that it is a certain grade of materials to send it out to a lab and have it tested, which may be more expensive than the actual materials were. So we're going to talk a little bit about how these material characteristics and the speeds that we can cut them at as we go forward with this as well. So it is important to know and understand what material we're using here as we go. This is something extra. I put this in. You kind of need to be familiar a little bit, and this was definitely going to relate to our cutting tools when we start to go into identifying cutting tools that are needed and insert selection. The ISO material group, notice the letter P, and it's indicated by the color blue, is our material group for steel. Now, I don't pay too much attention here to the color groups and the color grouping on these. We pay more attention to the letter and the material group. So letter P is steel. So letter M is stainless steel. Letter K is cast iron. Letter N is all your non-ferrous, your aluminums and other non-ferrous metals. Your S are your super alloys, your titaniums and nickel, cobalt, those different types of alloys that would be made with those. And then H is your hardened steel as well. And we'll get a little bit more into this, so I'm just kind of showing you a further breakdown here when we talk about this. You can see here that depending on what the actual material is, you're seeing some Rockwell ratings as far as the hardness, material type. Notice that we get some different tensile strengths out of here. So, once you learn how to kind of read these charts, you can have a better idea of the strength properties of some of this material as well. So, and this kind of breaks that down. This, of course, is pulled off of the website cabanaengineering.com, so you can kind of get a better idea by going onto their website and looking at some of that material there as well. Here, of course, is some of the additional ones and the idea here of machinability. So your machinability is more or less how easy it is for us to cut that particular metal. Now, there are all sorts of things that go into the machinability, and that as we take a look at it, sometimes it might be easier to drill, sometimes it might be easier to mill or to turn on a lathe, but there are a bunch of other variables that kind of play into that as well. The type of machines that we're using, the rigidity of the machines, so the work hardness of that. So as we sit there and take a look at it, it's not quite as cut and dry. So there are a lot of things that you need to kind of get familiar with and get to know. And of course, most of this is just going to come in time and practice as you get more experience in actually cutting the different types of materials and using the different types of cutting tools and machinery and setting those machines up. You'll start to develop more of a sense of problem solving based on these different factors and what's going on at the machine when you're actually trying to run a cutting tool through the material that you're cutting. So be aware of the machinability aspects, kind of have an idea of what it means, and know that you're going to need to actually experience this on the job a lot more to really get a better understanding and really be able to problem solve in this case. All right, so when we talk about metal, here are some of the 4 forms. This particular textbook discusses the 4 forms that you might see this material come to you. It talks about block, bar, and sheet goods. So it talks about castings, forgings, and extrusions. Now, I would probably make an argument that block, bar, and sheet are 3 separate things in and of themselves. But generally, when we are talking about block, bar, and sheet, you are generally getting those in the grade that you order. So for example, if I wanted like some 4140 or which is a pretty common alloy that's used a lot, I can get that in square, rectangular bar. I can get that in round bar. I can get that in big, gigantic plate. So, which I assume is what they're referring to when they say block in this textbook, or I might get that in sheet goods as well, which would be generally thinner than plate as well. So, now from there we get into all sorts of different types of castings. You get into forgings and extrusions, and each of these bring up a different strength characteristics and different advantages and disadvantages to use each depending on what the application is and what we need to machine it. Certainly here in Decatur, if you are going to work for Caterpillar, you're going to be using a lot more forgings and castings because they use a lot of forgings and castings on their large parts. It saves them machining time, so they don't have to go in and spend a whole lot of time machining stuff out of gigantic plate. If you're going to work for Mueller, so you're going to be predominantly working in a lot of the brasses and bronzes, and again, those are typically going to be castings as well. They've got the outside, and then you're going to have special fixtures to hold them, where you're just going to basically be doing lighter type machining. If you go to a job shop or machine shop like what I'm used to and where I serve my apprenticeship, you're going to basically be more or less using a lot of bar stock, a lot of high-speed steels, a lot of tool steel, maybe even aluminum, where you're basically turning that part, and you're going to be really concerned with maximum material removal, trying to remove that material and get that material off of that bar and into the shape that you need it to be as quickly and as fast as possible. Well, I should kind of back up here for just a second, because while I'm saying that, from my background, any machine part, no matter what, the goal is, of course, to remove that material and get that material removed as fast, as quick, and as efficiently as we possibly can. So as we look at all of these different types of forms, you will notice that there will be different advantages from one over another. And with that, I think this is a pretty good spot to stop on this particular one. So I'm trying to kind of limit the amount of time on each of these to make it easier for you guys to watch them as you need to. So I'll come back here. So we're going to stop this particular point in the PowerPoint, and I will come back with another video where we'll go into the differences between block, bar, and sheet, castings, forgings, and extrusions.